Next, we're going to analyze the graph of the rational inequality to solve it. Again, graphically, you can sketch your own graph. You can look at the graph that's in the calculator, but if you use your calculator graph, make sure that you're paying attention to the characteristics of the graph that we've been talking about, because it's really easy to lose parts of a rational graph. So if we look at this one somewhat by hand, then we know we're going to have x-intercepts when y is equal to 0, f of x is y, and so that's going to happen when the top of the fraction, the numerator, is equal to 0. If you set x squared minus 4 equal to 0, you get zeros at plus or minus 2. We know we're going to have vertical asymptotes when the denominator is equal to 0. So if we set that equal to 0, we get vertical asymptotes at plus or minus 3. We also know that to get our y-intercept, we're going to let x be 0. And if x is 0, then these two x squares are both going to 0, and we get negative 4 over negative 9, which simplifies to 4/9. So that's our y-intercept. X-intercepts are negative 2 and 2. We can plot those on the graph. And then, like I said, the vertical asymptotes are at plus and minus 3. Now the horizontal asymptote, don't forget about your horizontal asymptote, occurs, or you can tell what it is by looking at the highest power of the numerator, which is 2, and the highest power of the denominator. If those powers are the same, then your horizontal asymptote is at the ratio of the leading coefficients, which is 1 over 1. So our horizontal asymptote is at y equals 1. Now we just need to fit our graph in here. We know we don't have any other x-intercepts, so our graph is going to have an arm up here. It's going to come through our x-intercepts and y-intercept there and turn down. And then over here, the arm has to be up here because we can't have any other x-intercepts. You can always double check this in your calculator because now you know from your algebra that you did where the important parts of the graph are. Now we want to just look at the graph and tell where the function is greater than or equal to 0. Remember, equal to 0 is on the x-axis itself, so we do want to include the negative 2 and the 2 because of that equal sign. Greater than 0 is above the x-axis, so we want these arms that are above the x-axis, and then also this little top part of the U shape that's above the x-axis. So those are shaded in green. Notice that you can get a sign change from negative to positive or positive to negative at zeros on rational functions, but you can also get a sign change from positive y values, like on the left over here, the left side of the vertical asymptote, and on the right side you've got negative y values. And at the next asymptote we have negative y values, and then we have positive y values. So we can have that change in sign not only at the zeros but also at the vertical asymptotes. So when we are doing our work algebraically in the next video, we'll need to remember that we need to check the zeros and we need to check the vertical asymptotes for sign changes. Okay, the only thing left graphically is to write the intervals on which the function is above the x-axis. So that would be from negative infinity to negative 3, not included negative 3, from square brackets negative 2 to square brackets 2 because we do want to include those zeros, and then from 3 to infinity, not including the 3.